Hello. So today's topic is on ordinary differential equation. Next topic according to the syllabus of mathematical physics as mentioned by the CSIR-NET. So ordinary differential equation. So first question is from 2019 June. It reads as the solution of the differential equation x dy by dx plus 1 plus xy equals to e to the power minus x with the boundary condition y x equals to 1 is equals to 0. So now we will solve this by little manipulation that we will do as follows: x dy by dx plus 1 plus xy e to the power minus x dy by dx 1 plus x by x, dividing by x on both sides of the this equation, above equation, we get this one. This is linear differential equation of first order. This is of the form you must remember. You must have done in 11th and 12th in the intermediate. It is like this. Okay. So for the following equation, we have integrating factor e to the power p dx, and solution is given by y into integrating factor q multiplied by integrating factor dx plus c. Okay. Now similarly, we will do the solution. Y into integrating factor is e to the power p dx. Here p is 1 upon x plus 1 dx. Okay, so we get e to the power ln x plus x, which gives e to the power ln x e to the power x. This becomes x e to the power x. So integrating factor is x e to the power x. Now y multiplied by integrating factor, this becomes q multiplied by e to the power minus x upon x multiplied by x e to the power x dx plus c. C is the constant of integration. X cancels, this becomes x plus c y x to the power e to the power x y is equals to divide by x e to the power x. This becomes x plus c. So divide by x e to the power x, this becomes so we are given the boundary conditions as y of 1 is equals to 0, y of x equals to 1 is equals to 0. So if we put x equals to 1, then y is 0. We put in this above equation. This is the solution of the differential equation that we have solved for. E to the power minus 1 plus 1 multiplied by c e to the power minus 1. This is e to the power minus 1 plus c. So either e to the power minus 1 is equals to 0 or 1 plus c is equals to 0. So for that case, e to the power minus 1 is not 0. We already know that. So therefore c is equals to minus 1. So constant of integration is found to be minus 1. Now we'll substitute in the solution. This reads as y equals to e to the power minus x plus, sorry, that will be minus 1 upon x e to the power minus x. So this is the solution of our given equation, given differential equation, which can be written in more simplified form as e to the power minus x minus 1 upon x. So option A is the correct answer. Okay. Next question is from 2018 December. In terms of arbitrary constants a and b, the general solution to the differential equation is given like this. So this above equation, x squared d2y by dx squared plus 5x dy by dx plus 3y is equals to 0. So above equation is of the form of Cauchy-Euler differential equation of second order, right, which is of the general form. I will write the general form as e2 x square d2y by dx square plus a1x dy by dx plus a0y qx, right? So here we will make the substitution as let x is equals to e to the power z. This becomes ln x equals to z. Take the logarithm on the both sides, we get this one. Now differentiate with respect to now differentiating this equation, we get 1 upon x dx equals to dz. This becomes 1 upon x dz by dx. Then dy by dx can be written as dy by dz by dx 1 upon x dy by dz, right? Since dz by dx is 1 upon x, substituted the value from this. Okay, so this becomes x dy by dx equals to dy by dz. Okay, now taking the double derivative of the above equation, d2y by dx square equals to d by dx of dy by dx, right? This becomes dy by dx is already this one, 1 upon x dy by dz, d by dx of 1 upon x dy by dz. This becomes minus 1 upon x square dy by dz plus 1 upon x d2y by dz square dz by dx. Okay, okay, now simplifying more, dy by dz plus 1 upon x square, dz by dx is what? Dz by dx is 1 upon x. Substituted that, we get the following, d2y by dx square. Okay, now take the x square or multiply on both sides, x square d2y by dx square minus dy by dz plus d2y by dz square. So now we will substitute these values of x dy by dx, and x square d2y by dx square. We get the following equation. Cauchy-Euler differential equation of second order reduces to this form: a2 d2y by dz square plus a1 minus a2 dy by dz plus a0y equals to qz. Q is a function of z now. Right? Now our differential equation reads as x square d2y by dx square plus 5x dy by dx plus 3y is equals to 0. Here a2 is 1, a1 is 5, a0 is 3. Substituting these values in this equation, we get d2y by dz square plus a1 minus a2 means 5 minus 1, that is 4, dy by dz plus 3y is equals to 0. Now we write the auxiliary equation as d square plus 4d plus 3 is equals to 0, m square, this is the auxiliary equation, m square plus 4m plus 3 is equals to 0. This becomes m square plus m plus 3m plus 3 is equals to 0. m plus 1 plus 3 m plus 1 is equals to 0, m plus 3 and m plus 1, this is equals to 0. So m is found to be m equals to minus 3 or m is equals to minus 1. Okay, now the solution will be a e to the power minus 3z plus b e to the power minus z, a x to the power minus 3 plus b x to the power minus 1. This becomes a by x cube plus b by x. So a by x cube or b by x, so it should be denominator should be x cube and an x. It doesn't matter whether the coefficients are a or b with them. So option 4 is the correct answer. Okay, option 4 is the correct answer. Okay, now so our next question is from 2018 June. Consider the following ordinary differential equation: d2x by dt square plus 1 upon x dx by dt square minus dx by dt is equals to 0 with boundary conditions which reads as x of 0 is equals to 0 and x of 1 is equals to 1. Then value of xt at t equals to 2 is. Now in order to solve this type of equation, this term is little bit troublesome. So what we do is, let us assume x square is equals to z. This gives us 2x dx by dt equals to dz by dt. Again we differentiate with respect to t. We get 2 dx by dt equals to plus 2x d2x by dt square equals to d2z by dt square. This gives dx by dt square plus 2x d2x by dt square, d2z by dt square. Then divide by 1 by 2x, we get dx by dt whole square plus d2x by dt square equals to 1 upon 2x d2z by dt square. So we substitute the given in a differential equation by this and this. We get the following: 1 upon 2x d2z by dt square minus 1 upon 2x dz by dt is equals to 0. Multiply by 2x, equation is reduced to, differential equation reduced to d2z by dt d2z by dt square minus dz by dt is equals to 0. Now d square minus d of z is equals to 0. Auxiliary equation reads as m square minus m is equals to 0. M of m minus 1 is equals to 0. M is equals to 0 and m is equals to minus 1. Solution will be of the form z is equals to e to the e to the power 0 plus b e to the power minus this is m equals to 1, b e to the power t. So a plus b e to the power t. Now since it was assumed that z is equals to x square, this becomes x square equals to a plus b e to the power t. Now the boundary conditions are x of 0 is equals to 0, x of 1 is equals to 1. This becomes a plus b, and another one, by imposing the other condition we get a plus be. From above equation, from first equation, p is equals to minus a, and here it becomes a minus ae. A is 1 upon 1 minus e, and b is minus of a, that is this. Now we write the equation as, now the solution changes to this form: x square 1 upon 1 minus e minus e to the power t 1 minus e. Okay, now x square is equals to 1 minus e to the power t upon 1 minus e. Now what we have to find is the value of xt at t equals to 2. When t is equals to 2, xt square equals to 1 minus et 1 minus e. So at t equals to 2, xt is x square 1 minus e square 1 minus e. This becomes 1 minus e 1 plus e. This is 1 minus e, 1 minus e, 1 minus e cancels, 1 plus e. X equals to square root of 1 plus e. This is the required solution. So option C is the correct answer. Option 3 is the correct answer. So option 3 is the correct answer. Now another question is from 2017 December. The number of linearly independent power series solution around x equals to 0 of the second order linear differential equation x d2y by dx square plus dy by dx plus xy is equals to 0 is. Now this equation resembles to Bessel's differential equation. So remember this: Bessel's differential equation reads as x square d2y by dx square plus x dy by dx plus x square minus n square y is equals to 0. So this is the Bessel's differential equation. Okay. Now in our case, the differential equation reads as x d2y by dx square plus dy by dx plus xy is equals to 0. Now multiply with x to the whole equation, we obtain x square d2y by dx square plus x dy by dx plus x square y is equals to 0. Now this resembles to the Bessel's differential equation. What we see is here n is equals to 0, here n is equals to 0. So Bessel's differential equation has the solution j0x. So only j0x is the possible solution, since n is equals to 0. So option 1 is the correct answer. This equation does not have a power series solution. Now another question is from 2017 June. The function yx satisfies the differential equation x dy by dx plus 2y equals to cos pi x by x if y of 1 is equals to 1. The value of y of 2 is. Now this equation is again of the similar pattern which we did the first question. X dy by dx plus 2y is equals to cos pi x by x dy by dx divide by x 2 by x y equals to cos pi x by x square. Again it is of the form dy by dx plus py equals to q. Here integrating factor becomes e to the power p dx, which is e to the power 2 by x dx, e to the power 2 ln x. This becomes e to the power ln x square, and this is the integrating factor. Integrating factor is x square. So y multiplied by the integrating factor is equals to integral of q multiplied by integrating factor dx plus c, constant of integration. Y multiplied by integrating factor is yx square, q is cos pi x by x square multiplied by integrating factor is this, dx is plus c. X square cancels. Now cos pi x dx will give, integration of cos pi x will give sin pi x by pi plus c. Divide by x square from whole equation, sin pi x by pi x square plus c by x square. Now here boundary condition is given as y of 1 is equals to 1, y of 1 is equals to 1 is equals to sin pi by pi plus c. Sin pi is 0, so c is equals to 1. So solution will be sin pi x by pi x square plus 1 by x square. So we have to find the value of y of 2 is y of 2. So y of 2 is sin 2 pi by 4 pi plus 1 by 4. Sin 2 pi is 0, y is equals to 1 by 4. Y of 2 is 1 by 4. So last option is the correct answer. Option 4 is the correct answer. Okay. Now another question is from 2015 December. The solution of the differential equation dx by dt is equals to 2 under root 1 minus x square with initial condition x equals to 0 at t equals to 0 is. So this equation can be solved very easily, given as dx by dt 2 under root 1 minus x square dx by 2 under root 1 minus x square dt. Keep the 2 here only. Okay, so integrating on both sides, we get sin inverse x equals to 2t plus c. So x equals to sine 2t plus c. C is a constant of integration. Now applying the condition, that is the boundary condition, that is at t equals to 0, x equals to 0. This becomes sine 0 plus c, that is sine c is equals to 0, which means c is equals to n pi. So x equals to sine 2t plus n pi, which reads as sine 2t when n is equals to 0 to 4, minus sine 2t for the case when n is equals to 1, 3 and 5. Okay, so from the given options, x equals to sine 2t is the correct one. So we have two options, this one and this one. Now as you can notice, dx by dt, which is given like this, 2 under 1 minus x square, this is continuous in nature. Dx by dt is continuous. Therefore the solution of the differential equation and its derivative should be continuous in nature. So if we see, when for option second, if you can see sine 2t by 1, sine 2t for the limit 0 less than t less than or equals to t less than pi by 2, and 1 for t greater than or equals to pi by 2. If you can see the differential equation for the second option, when we put x equals to sine 2t for second, I will do here for option 2, put x equals to sine 2t. So dx by dt becomes 2 under root 1 minus sine square 2t, which will be 2 cos 2t. Now when t is equals to pi by 2, this becomes dx by dt becomes cos pi is minus 1, that is minus 2. Now for the other case, when t equals to pi by 2, this one, x is equals to 1, so dx by dt will be for t greater than or equals to, for dx by dt will be 0. So for the same value, that is x equals to that is for t pi by 2, both are different. So it is option 2 is not continuous in nature. Now let's check the option 3. Option 3, for pi by 4, dx by dt becomes 2 cos 2t. So when t is pi by 4, this becomes 0, dx by dt is 0. Now for t greater than or equals to pi by 4 also, when x is equals to 1, so for the similar case, this is again 0, dx by dt is again 0 in both the limits. So option 3 is the right answer because it is continuous in nature. Okay, option 3 is the right answer. Now the last question is from 2015 June. Consider the differential equation d2x by dt square minus 3dx by dt plus 2x is equals to 0. Boundary conditions are given as x equals to 0 at t equals to 0 and x equals to 1 at t equals to 1. The value of x at t equals to 2 is. Now we solve this again as we write the equation as d square minus 3d plus 2x is equals to 0. Auxiliary equation reads as m square minus 3m plus 2 is equals to 0. So m square minus 1m, we take the factors, is equals to 0. M is equals to m minus 1 minus 2, m minus 1 is equals to 0, m minus 1 and m minus 2 is equals to 0. So m is equals to 1, and m is equals to 2 are the two values of m. So solution will be, this is x a e to the power t plus b e to the power 2t. Now the boundary conditions are as x of 0 is equals to 0 and x of 1 is 1. So we put this in the solution of the differential equation. This becomes a plus b is equals to 0. Another equation is 1 is equals to ae plus be square. Now we can solve this. B is equals to minus a, and this equation becomes 1 is equals to ae minus ae square. A will come out to be 1 upon e minus e square. Now we substitute in the above equation the solution, that is 1 upon e minus e square, and b will be minus of e minus e square. So this will give e to the power t minus e minus e square e to the power 2t. Now we have to find x at t is equals to 2. So x of 2 is equals to e square upon e minus e square, wait, hold a second, e to the power t minus e to the power 2t upon e minus e square. Now let's substitute. T is equals to 2, and for other case it is e to the power 4. Now we'll say e minus e square. This is of the form a square minus b square. So e minus e square, e plus e square. This becomes e minus e square. E minus e square cancels. So x of 2 is equals to e plus e square. This is the correct answer, e plus e square. So option 2 is the correct answer. Option 2 is the correct answer. So this finishes our topic of ordinary differential equation. Thank you for watching. Take care and stay safe.